Well, hello and welcome YouTube to Mr. Robinson's Q&A Power Hour here on April 28th. It's actually on a Wednesday evening. I wanted to get this out earlier in the day. I was not able to. I had a lot of other obligations to take care of. This is for my classes who have to... Sorry, I just did a recording or I did a Zoom thing for somebody else. This is for my Integrated Math 2 classes who actually have a test tomorrow, group test, and then an individual test over the weekend. So I made sure they could get their questions in so I could answer them as soon as possible. Hang on, where did I put them? I just pasted them in and now I gotta find them. There they are. Okay, so if you haven't been to a chalk talk, I just did a chalk talk. If you haven't been to a power hour, I should really redo this video. If you haven't been to a power hour before, all this is basically, I'm not gonna spend an hour. I see 7 questions. No, these questions seem fine. So I'm gonna spend some time taking their questions that they ask and I answer them, and then those students at some point can follow up and answer those questions to their liking. And yeah, that's kind of going to be it. All right, so let's go and take a look at their questions here. Let's start with question number 1. And the first question asks, is the unit test going to be a group test? Well, that's not a content-related question, and there are always 2 tests. There's a group test and an individual exam. So I don't know if that answers it, but there it is. Next question, do other shapes have branches like quadrilaterals branch out? You mean like exterior? Oh, I know what you mean. I first thought you meant like exterior angles. So what they're talking about is, you know, when you have a the quadrilateral is a 4-sided shape, but when you do certain things to the quadrilateral, it takes on like a unique name. Like if you make all sides parallel, opposite sides parallel, it becomes a parallelogram. And then if you give the parallelogram right angles, you have a rectangle. Or if you give a parallelogram equal sides, you have a rhombus and all that kind of stuff. Or if you give one pair of sides parallel, you have a trapezoid. So I think that's what they're asking. So do other shapes, basically do other polygons kind of have that? Well, triangles do. Triangles have, there's the right triangle, obtuse triangle, acute triangle, or the scalene isosceles or equilateral. You can kind of name them with both names based on what you're talking about. Every other thing, like a pentagon or a hexagon or a heptagon, octagon, nonagon, decagon, things like that, 5, 6, 7, 8, 9, 10-sided shapes, they can be called a regular pentagon, regular decagon, regular octagon. So I could make some sort of weird, whoops, hang on, wrong button. I could make some sort of 5-sided shape, any old pentagon, like this guy here. It's still a pentagon. It's a 5-sided shape, right? And then there's the regular pentagon, which looks like that. There's got to be names for some of the others. Obviously, well, circle always has to be a circle, but you can have other curvish shapes like an ellipse and things like that. I don't know. I think at that point you're just either calling it a regular something or something like that. Otherwise, it's I think it kind of just keeps its shape. There are some things you can do with them when we get into 3D. Not when we do, but when you start exploring some 3D stuff and make tesseracts and tetrahedrons and stuff like that. But no, the quadrilaterals are, there's a reason we get into quadrilaterals in that way. And all of them have different formulas for finding their area based on that. Whereas once you get into the pentagon, hexagon stuff, the area conditions are kind of the same once you, for regular ones, once you learn what to do. So anyway, I think that's as deep as you really get into it. Otherwise, triangles, yeah, triangles do for sure. All right, how do you do the 180 times n minus 2 equation? I'm not quite sure how it works. So what that formula says there, when you do d equals 180 times n minus 2, well, you got to see what this is for. D is the number of degrees of the interior angle sum of whatever polygon you're talking about. And n is the number of sides of that polygon. What we're doing with that is whenever you have a pentagon, for example, like the one that I just drew, the one that was, like that. Okay, so see how that's a 5-sided shape right there? And see how this is a 5-sided shape? Both of them have 5 interior angles. This has 5 interior angles. 1, 2, 3, 4, 5. This has 5 interior angles. 1, 2, 3, 4, 5. You know what's true about both of these pentagons? Their interior angle sum is the same. It's 540 degrees. If I substitute 5 into this equation, 5 minus 2 is 3, 3 times 180 is 540. The interior angle sum of both these is exactly and always 540 degrees, no matter how I manipulate the pentagon, no matter what I do to it. As long as it's a 5-sided polygon, it will always be that. If I take this thing and I do this to it, and change it like that, you know what its interior angle sum is? 540 degrees. And that's what the formula is doing. It's allowing you to say, we well, it gets us the interior angle sum, so then when they get us a breakdown telling us, oh, this is 40 degrees, and this is 160 degrees, and this is, 32 degrees, and this is X degrees, and this is 10 degrees, whatever, blah, 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 that doesn't seem like that's all correct. But anyway, you say, solve for X, well, we know that all of these will add up to 540, because when I substitute 5 into there, that happens. If I ask for a 100-sided polygon, you can plug 100 into here, and you could figure out its interior angle sum. But D is the interior angle sum, what all these add up to. And you use this side to calculate what they all add up to. This is what allows you to then solve for a missing variable or something like that. And that's all that thing does. That's what that's for. Okay, the next question here. I want to go fast with this one tonight. The next one asks, how do you tell a rhombus for a parallelogram if they look the same? Well, parallelograms, rhombuses are parallelograms. So I think I know what you mean when you say if they all look the same, because for the most part, whenever we draw a rhombus, we give it kind of this look here. Like, hey, it looks like a parallel, because we always think of like this is going to be a top and bottom that are flat and these are parallel and stuff. As long as these are congruent, though, it's a rhombus. How can you tell the difference? Well, you're going to have to be, well, here's a way. If you were told this was a parallelogram or whatever and you have all sides congruent, then you know it's a rhombus. If they tell you it's a rhombus, then you know it's a rhombus. If the diagonals are perpendicular, then you know it's a rhombus. Or if the diagonals bisect the angles, then you know it's a rhombus. Basically, you got to go off the rhombus properties. So if they told you those two are congruent, something like that. Any of these things you're seeing here are things that are cluing you into it's more than just a parallelogram, if you knew at the very least it was a parallelogram. Not all rhombuses or rhombi, however you say it, are drawn the same, though. I've kind of shown instances of them where I've really flattened them out, and I've done like, here's a diamond version of one, where you don't see parallel on top and bottom, you just see kind of a diamond-shaped version. And that's a rhombus, because all four of these sides are, just to pretend like they are, all four of these sides are congruent here. How can you tell? Again, you go off the properties, the names, the information, stuff like that. But all rhombuses are parallelograms, so make sure you know that. Just how can you tell if a parallelogram is a rhombus? All four sides congruent, or diagonals bisect the angles, or diagonals are perpendicular with each other. Those are things that you can do to add on top of the fact that a parallelogram already has opposite sides parallel, opposite angles congruent, consecutive angles supplementary, diagonals bisecting each other, things like that. Rhombus just adds on to it. So I don't know if that answers that, but if they give you other information, if they tell you it's a rhombus, there it is. Otherwise, all rhombuses are parallelograms, and otherwise it's just a parallelogram. So hope that kind of answers that there. Here we go. Next question. If you have a triangle and you are being asked to find the missing angles, but the triangle has a linear pair, can the angles that are not the linear pair be adjacent? Okay, hang on, I have to draw this. If you have a triangle, I'm going to draw a triangle, and you are asked to find the missing angles. So I'm drawing a triangle here. You're asked to find the missing angles, but the triangle has a linear pair. So are you saying an exterior angle? So let me add it like that. Can the angles that are not the linear pair be adjacent? I think I have the setup. I don't know what your question is. So I know we've talked about remote exterior angle theorem. I don't know if that has to do with that here. I'm just going to give letters. X, Y, Z, and then W on the outside. That's fine. I don't know if I'm going to answer your question. I'm just going to kind of speak on this stuff. Just whatever. Just to kind of clue some people in on some things and really make sure we have the word adjacent in the right way. All right. We do have here the interior angle sum of any triangle is 180 degrees. That's where that formula comes from. I really should have probably answered that other question. You're not sure how this works right here. This person, I'm not diving into the reason behind the formula there, but it has to do with the number of triangles that are inside your shape. There are 3 triangles inside a 5-sided shape. That's why you do 180 times 3, things like that. Anyway, the interior angle sum of this triangle is 180 degrees right here, x plus y plus z. The remote exterior angle theorem says that if you add the 2 non-adjacent angles to the remote exterior, that's you saying adjacent there. If I add these 2 angles here that are not adjacent to that exterior angle, then it does equal that angle. X plus y equals w. That's true. And it's also true that z plus w equals 180 because they're a linear pair, kind of as you stated, assuming that's what we were talking about there. So those are 3 different things that you can exercise within properties of this triangle. I'm not assuming it to be isosceles or equilateral or anything like that. So your question is, can the angles that are not the linear pair be adjacent? So you're asking if these 2 are considered adjacent? Because these 2 are the linear pair. Can these 2 be adjacent? Adjacent angles, well, these two angles aren't adjacent to each other. These two angles are adjacent to each other. These two are non-adjacent here. To be adjacent, you have to share a common side, which these do. They share a common side, but they don't share a common vertex like these two do right here. Right? W is also remotely distant from these two as well, but these two are non-adjacent. You might call these vertices adjacent. If I start to get to a larger shape, let's go back to a pentagon, like I drew earlier. If I have a pentagon right here, I would call, if this was pentagon A, B, C, D, E, I would call A and B adjacent vertices, because adjacent is kind of like they're next to each other, they neighbor each other. These are called adjacent vertices. A and C are not adjacent vertices, but A and B are, B and C are, things like that. But angles, adjacent angles, have to share a common side and a common vertex. So anyway, I don't know if I answered your question, but X and Y are non-adjacent. They're not a part of the linear pair. They are non-adjacent there. All right, what are consecutive angles in parallelograms? Well, you can call these things consecutive angles right here. Well, here's the thing. There are one of two angle types in parallelograms. There are opposite angles, which I'm sure you know what those are. These in green are opposite angles. These in blue are opposite angles. And then there are consecutive angles. The word consecutive means one after another. It means in a row. These in purple are consecutive angles. This angle and this angle. They're not adjacent. The vertices are adjacent. They're not adjacent, but they are consecutive angles, one after the other. So something in a parallelogram says consecutive angles are supplementary. If this measures x and this measure is y, in any parallelogram, x plus y equals 180. So when you hear consecutive angles are supplementary, that's what that means right there. Anyway, hope that answers that. Yeah, so all this vocab, it's kind of all, they're consecutive angles, but adjacent vertices, but non-adjacent angles. It gets a little screwy. But anyway, yeah, in a parallelogram, it's the angles that aren't opposite each other. It's the ones that are next to each other. Those are called consecutive angles. All right, and the final question here is, what are the differences between an acute, obtuse, and right triangle? Well, the main thing is the largest angle in the triangle. Here's an example of an acute triangle. Here's an example of a right triangle. Here's an example of an obtuse triangle. Now, the thing about the three here is that you have to have two acute angles in each thing. I'm not marking congruency here, by the way, guys. I'm just saying what are acute. These two are acute. These two are acute. These two are acute. In any triangle, two angles have to be acute. Now, there's a third one here that's acute. That's why we call this one an acute triangle. This one's a right angle. That's why we call that a right triangle. And this last angle, the largest one, is an obtuse angle. That's why we call it an obtuse triangle. But again, the others have to be acute. Why? Because all three angles have to add up to 180. Not just by math, just by nature of triangles. So if you have an angle that's 90 degrees, how could either of these other two angles be 90 degrees or more? 90 plus 90 itself is already 180. You need the other one to have an angle measure. So the other two have to add up to 90 in a right triangle, and these two have to add up to something less than 180. Basically, the other two are acute, but it's based on the largest angle here. What's the difference among them? The largest angle. The largest angle in this one's acute. This probably isn't the largest angle, but you know, all angles in this one are acute. Two of the three are acute here, two of the three are acute here, but the largest angle here is right, the largest angle here is obtuse. All right, and that'll be it, guys. I'm going to cut this one short here. That's going to be it for Mr. Robinson's Q&A Power Hour. I hope that this was helpful to you. Thank you for watching. Take care.